Question number 3. A mass is suspended by a light string from the roof of a car. The car is accelerating up an incline. Okay, it is accelerating like this over here with an accelerating A. What is the free body diagram for the mass? Okay, so what's happening over here? Tension will act like this over here. mg will act like this over here. mg will act vertically downward like this over here. mg will act like this over here. Now, if A is acting like this, then what can happen? This tension can be split into two parts, right? So one along this direction, which you can say, if this angle is theta, I can say this will be equal to t cos theta like this, and maybe I can now write something like this over here, which would be t sin theta here, right? I can write like this over here, and if this has to be in equilibrium, see, this has to be in equilibrium, then this t cos theta should be equal to mg, which means the length of this line and the length of this line should be exactly the same. If this line has to be the same, that means this tension vector that I write here should be larger. Okay, should be larger than this vector over here. Are you getting me? See, if this is the line, this is your component, this is your mg vector. If this has to be equal to this, this definitely has to be larger. Why this has to be larger? Because you see, if this is theta, okay, let me say for example, this is O, this is A, this is B over here. So we know that if I want to do something like this, I can say OA cos theta, that's what I have written, right? Tension cos theta is equal to upward vector, OB vector. Okay, so definitely when there is an angle theta, cos theta will reduce this value. So as a result of it, it should be lesser. So thus OA cos theta should be equal to OB should be the condition. So now let us look at this over here. So where do we have this kind of condition? See, you can see this kind of condition in option B over here. So here it is not possible. See, what will happen is this will act like this will act like this, but there is an other force acting like this over here. So therefore this is not possible. So if this was a force acting here, the bob would have moved in this direction also, which is not been seen. It is equilibrium vertically. Now here what happens? So if I take this one, this vector would only be so much. Okay, so this will break the string over here and fall down. So here what is happening? So this one, this vector is lengthier over here. See, what do I do is I just draw the projection here. Draw a straight line here and draw a perpendicular here. So this is the vector over here. This vector is larger than this vector. So you can expect the particle to go upwards. That's not happening. So as a result of it, B is the right answer.